acento irlandés es entendible o no. So welcome to the Web of Data. Today I'm going to give an introduction to the area. I'm going to motivate the topic. And I'm going to explain a bit about the grading of the course and so forth. So in general, this is a postgrad course, but of course, undergrads are also more than welcome to take the course. And it relates to an area of research, the area of research that is my main area. So it has to do with the web, of course, as you might have guessed from the title. So the web is now over 3 decades old. So it's been around for quite a long time, and there's no need to explain the importance of the web to you. I think you will understand how important it has been. Question is, what about the future of the web? So what do we think the web will be like in 3 decades time? Right, so if we think about it, we might have some ideas. We might think that somehow we might think of some sci-fi movies and think about different fancy ways of interacting with the web. However, in general, this relates more to the interfaces of the web, right? So one way in which I personally can see the web evolving is something called the semantic web. And this is sort of an area of research that has been ongoing for quite some time. So the concept of the semantic web, well, if I want to find out what something means, usually I'll type it into Google and hit search, and I'll find a description like this. For example, the semantic web will bring structure to the meaningful content of web pages, creating an environment where software agents roaming from page to page can readily carry out sophisticated tasks for users. This is the quote from a seminal paper that described the vision of the semantic web by Berners-Lee et al. So Tim Berners-Lee being the inventor of the World Wide Web, of the web. So some years later, he was proposing this concept with co-authors of the semantic web. So, okay, what does all that mean? It's kind of hard to understand what this means. So essentially, the key part here is bringing structure to the content of web pages in order to enable greater automation in the ways that we use the web. So it's difficult to answer what is the semantic web. I can't give you a very direct answer. This is probably a pretty good answer, but equally it would be very difficult to answer the question, what is the web, right? If you imagine having to explain to somebody in 1989, what is the web? It would not be so straightforward, and it would not be so easy to motivate it either. You know, you could say, oh, well, you can look up information. Well, you can go to the library and do that, or you can buy products. Well, you can go to a store and buy products. So essentially, the concept isn't really captured by the definition. So I'm going to talk a bit more about that. But before we talk about what is a semantic web, it's very important to establish what's wrong with the current web. So if there's nothing wrong with the current web, if it's perfect, then well, we don't need this semantic web. Okay, we don't need this other version or alternative version of the web. So the current web is fantastic. This is one of my favorite websites, sometimes red, sometimes blue.com. And there's lots of very good websites, including Google. So in Google, I can do various searches, and it tends to know what I'm looking for. Yeah, the results are impressive. So for this search, I've said movie, what's in the box? Anyone know what movie this is?
Seven,
yeah. So Google knows. Also, if I search for Da-Da-Dum Symphony, okay, you might have seen this in another course if you've taken another course with me. Google will know to return. Anyone know?
9.
Fifth, I think.
Fifth. I
Beethoven's.
Sorry.
That's all good. Beethoven's Fifth Symphony, da, 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 dum, and so on. And Google can even predict what we're going to search for. If we start typing in a search, it can figure out what we might be interested in looking for. So Google works very well, and this allows us to Google or the search engines play a very important role in the web because they allow us to find the information we're looking for very efficiently in many cases, but not in all cases. So if we consider a case where Google won't work very well to help us, we'll consider the following problem. So we have a web user who's doing a report for university, and she wants to find all Nobel Prizes in literature who fought in at least one war, the year they won the prize, and the year the wars started. So if you had to solve this problem, you were doing a report on the effects of war in literature, for example, how would you solve this task on using the web? So clearly all of the information pretty much should be on the web, right? We would expect the web to be able to answer this, right? It should have, of course, Nobel Prize winners in literature. We should have information about the wars and if these people fought in wars, the year the person won the prize, and the year the war started. So the information is on the web, or we can assume that, at least. It seems reasonable to assume. How would you create this answer? How would you solve this problem?
In Wikipedia?
Yeah. So you'd end up going to maybe Wikipedia, right? You'd end up, finding the list of all the Nobel laureates in literature, and then you would expand the first one, okay, in the list. You click here, that would open another tab, and then you would maybe Control F here and look for war or conflict or civil or battle or something like that. Various keywords. You might find, for example, mention of the Franco-Prussian War here. So you click there and then you find out the date. So now you've got the winner, the year, the date of the war and the war. And then you can continue to the next Nobel laureate and search for keywords relating to war here again. So this is obviously quite an arduous or difficult task, right? So a lot of work has to be done here. And it's also kind of imprecise, particularly if finding within the article if that person has fought in a war or not, because there might be different words. It might not say war precisely. It might use a different term, conflict or battle or whatever it might be. So this is not ideal. And this is not easy to do on the web right now. And the main reason why it's not so easy is because, well, what we're doing is we have to integrate information from several different web pages or different websites. Well, in this case, one website, Wikipedia, but we have to integrate it from several different pages on Wikipedia. And there's no automatic way to help us do that. So to kind of go over the process, we're looking for all the Nobel Prize winners in literature in the list on Wikipedia. And then we have to find the year that they won the Nobel Prize. And then within each, we have to search some keywords for indicating war. And then for all of the wars in here, we need to go in and we need to find what year it started, considering here that one Nobel Prize, one Nobel laureate in literature may have fought in several wars. We need to find out the starting year of each of those wars, and we need to finally add this to the results. So we copy it and paste it into a spreadsheet, for example. So this is a very time-consuming task, and it's also maybe somewhat imprecise here in this definition of the keywords to use. So, okay, ideally, maybe eventually in 6 decades, what we could have is just essentially this semantic web that allows us to just directly find this information for us, and everything is automatically processed, right? So, okay, how do we do this? Well, if we think about it, there's nothing really crazy about this idea, right? I mean, we all use databases, for example, and we could, if we had all of the data in a relational database, just ask this question very directly. So as SQL maybe. So why is it so difficult to, why not somehow maybe structure the web like a database to be able to enable us to do joins across different websites and web pages, for example? So that's kind of the concept that we will be considering for the semantic web, will be to structure the content of the web. So specifically why this query is so hard on the current web is because the data that we're looking for, the user is looking for, is not available on one web document. It's not available on one web page. So using Google, if we're looking for a web page, you know, Google is excellent at that. If the answers we seek are all on one web page. In this case, it's not the case because it's quite a specific question. Okay, so it's quite a specific question that the user wants to answer because she's doing a report for university. There are other types of questions that are not easily that are not addressable by the content of one web page as well, such as personalized or contextual queries. For example, if I want to find a local supermarket that sells all the ingredients of this recipe that I have, this I won't find on a single web page because it would, you know, nobody would have combined supermarkets in my location with that recipe before, right? And to actually do that would be time consuming to find out such information, assuming there was, you know, online shopping and so forth. Or to find you know, movies that have been recommended by friends of mine on that are showing currently in the cinema. These sorts of questions are difficult to do. So we might not even think that the web can help us solve these, even though we can manually extract the answers. So in summary, this query is difficult on the current web because the information is not available on a single page. We need to combine multiple content from multiple web pages, from multiple sources together. And Google won't help us with that. Google will help us find the sources, but not to combine them, right? So there's no way to automatically combine different sources on the web in the general case. Okay, so why not? I mean, we have years of relational databases, or decades of relational databases, decades of the web, decades of different types of databases. Why can't we solve this problem? So in a technical sense, the current web is document-centric. So essentially the web was invented as a way to publish documents and share documents over the internet, essentially. So we might have some web page and some example website here. And what we'll find is that it uses HTML, hypertext markup language, to describe the content of the web page. So we see some tags here. Then we start to describe a body. We have a heading 1, level 1 heading. And then we have some images, and we have some paragraphs on this European country, capital is Dublin, and so forth. Dublin includes a link to another web page where we have another HTML document here that describes the content or describes the capital. So, and so on and so forth. So this is essentially the current structure of the web, and it hasn't really changed all that much. It's still very much HTML centric. It's still very much document centric. The way that these pages are generated, and maybe, you know, the presence of JavaScript and so forth, the interactive elements of web pages has changed, but this overall structure of documents with hyperlinks between them hasn't changed all that much. So this is great for humans. They can read the document, you know, it can make sense more or less. And they can, if they're interested in something, they can click and find out more information about that, right? So a human reading this can understand more or less what the document is about. It's describing a European country, and there's a capital there somewhere, and that capital has a population of 1 million. However, okay, and it's called Dublin. And okay, maybe they have some background knowledge. All of these documents make sense in the context of, you know, some background knowledge about what is a country and what does population mean and about numbers and so forth, right? So they might also have some other background information that people in Ireland, like Guinness, for example. So this overall makes this makes sense to the human. They can contextualize this information if they speak the language. Of course, if we have maybe a document that's in Spanish and the user doesn't understand Spanish, well, Google Translate can help with that these days. But they might not be able to understand this content. So in this case, not understanding what the population might be because it's now in a language that they don't understand. The case is even worse for machines. So if we consider these web pages from the perspective of machines, they can't really read the documents in the same way. So effectively, if we were to just randomly replace or swap around all the letters from the perspective of the machine, the documents would look the same almost, right? So all I've done here is just replaced on a 1-for-1 replacement of different letters, right? So O is now I, for example. So this is essentially much more like what the machine sees, right? It's just kind of strings and some bytes for images, and it can recognize, okay, it can parse individual letters, it can parse the individual characters of the strings, but it has no idea what this document is about, right? So from the perspective of the machine, it has no idea of the semantics or the meaning of what these documents are trying to convey. This could be a document about anything from the perspective of the machine. So the machine has no real concept of what these documents are about. So what's the problem with that? What's the problem with the machines not being able to process the semantics of the content, the meaning of the content? What machines can do on the web right now is fetch documents. So essentially, you know, the user puts in a URL into their address bar. The machine then goes off and does a DNS lookup on this, finds the location of the server, contacts the server and says, I'm looking for the Ireland page. The server sends that back. And then this is serialized as HTML and displayed for the user. So this sort of way of communicating, storing, and visualizing web pages the machines can do quite easily on the web, right? This is a standard part of the web. Something that came a little bit later after the initial invention of the web were search engines, right? So with search engines as well, at least in the basic version of search engines, the user can enter a search. Okay, the machine sees it from this perspective. So I'll use this color to represent a sort of a human perspective where we kind of know what's going on. Here is the machine perspective. So I'm going to garble all the letters again so we don't understand what it means. But from the machine's perspective, we have a string of 7 letters. Okay, so what does it have to do? It then just has to go and say, okay, I have a string of 7 letters. Let's go and search for that string within different documents, maybe case insensitive search and so forth. And then it can return the documents that match. So it's a bit more complicated than that, but still for the kind of basic search engine functionality, it's just string matching, right? There's no real understanding of what's being searched for. So machines can do this very well and very efficiently using various tricks for different types of ranking and different types of normalization of words and different statistical methods, and now more recently machine learning methods. They can do this sort of stuff very well. What machines still cannot do, even in the era of deep learning and so forth, is they're not very good at combining sources of information. So the machine in this case has these 2 web pages, but if you ask questions to the machine that require somehow an understanding of the content of both of these web pages, the machine won't be able to answer so easily, at least, or it would be a very complex problem. So towards the semantic web, so what we would like to have somehow our machines are to structure the web such that machines can understand the web in a similar way to how humans do. So what does that mean? Well, it means that, okay, somehow both of us, the humans and the machines, share a similar conceptualization of what the content of the web means. So that essentially means that the machines can somehow do more of the work of humans that humans currently do on the web, in particular in terms of combining sources of information on the web. So, okay, we're talking here in dangerous territory about how machines think and how they reason and so forth. And you might say, well, machines can't think, they're not intelligent and so forth. It's just that we somehow lack the words to talk about whatever the machine is doing, right? It's not some philosophical stance I want to take to say that, you know, machines can think. In that context, there's an interesting quote by Dijkstra who says the question of whether computers can think is like the question of whether submarines can swim. We're just using a familiar word, in this case, swim, or whatever we want to use for submarines. And in a similar sense, I'm using the analogy of think or reason and so forth, and that will be common in the course, even though it's not necessarily the same thing as what humans do, right? So, okay, we're using this sort of human analogy of understanding, for example. Machine can understand the content of the web, right? I don't mean that in a very literal sense, just as an analogy with what humans do. So in the context of whether or not machines can think or not, whether they can be considered intelligent, there are some philosophical thought experiments about this. So one is called Searle's Chinese room. And the concept is that essentially we have a box that's more or less self-contained. And within that, we have an operator who has a rule book and has an input and an output to the box. So the concept is that here we receive in, which are somehow inputs, which might be a question like, how are you, or what is the weather like, or what's 2 + 2 = 5, right? And the operator has the questions are written in some Chinese language, Cantonese or Mandarin, or maybe the symbols are the same in both, I'm not sure. But the operator receives the questions and then has a detailed guidebook that describes how to transform inputs into outputs, right? So somehow how to create a reasonable response for this input. The operator does not understand the language, does not understand the symbols, just has a very detailed rule book, right? So, and in that way can produce a reasonable output. Okay. So the overall question then is, since this whole box here is somehow emulating an understanding of the language, is this somehow intelligence? And Searle's argument is that it's not really intelligence, right? But that doesn't actually really matter. I don't really, whatever answer you give, it doesn't really matter. What's interesting is this concept here that it's somehow similar to a machine, right? That we don't mean that the machine is going to understand the language in the same way we do, but if we have somehow a sufficiently structured input and somehow a rule book, then we can give very convincing answers that make it seem like the machine understands what's going on. So this is very similar again, where we have our sort of human context here in the input and the output, but in the middle we have this machine context where there's no real understanding in a human sense, but we can emulate human understanding. Okay, any questions thus far? You can also ask in Spanish, it's no problem. Okay, so if there's no questions or doubts, it's kind of general discussion thus far, right? So, okay, so in terms of natural language, what does this mean? Essentially, what we're talking about is being able to to take inputs expressed in this case in a natural language, English, as it was originally, and to be able to process outputs to provide answers for that. So, okay, this is now we're in the machine perspective, right? So we maybe remember what the documents were, but let's assume we never saw what the documents were about, right? So we have two documents here, we have some strings, we have an image, we have a link, and over these two documents, we have sufficient content to be able to answer this question, right? But the question again is, from the machine perspective, doesn't make any sense, right? It's just a bunch of letters, sequences of words, right? So this is sort of the problem, right? That if we don't understand somehow the question and we don't understand the content, how are we going to answer this? So the answer to this question is, of course, anybody want to try to answer? Okay, so the answer should be Uli Mosolo. Okay, so how are we going to get that, right? It seems difficult. So it's not going to work so well if we just consider the content of the web as it's currently structured, right? This is going to be a very difficult task to resolve from the machine perspective. So why is it difficult? Well, we can use multiple names to refer to one thing. Okay, so we can refer to, for example, a country like Ireland by its name in English, or its name in its code, its two-letter code, its name in Spanish, maybe a full name, Republic of Ireland, well, extended name. And these all refer to the same country. Well, more or less, there are some political questions around Republic of Ireland, but anyways, they refer to the same country. So we can name one thing in multiple different ways. Whereas in terms of the machine just sees this as 4 different strings, right? It's not that it knows that these refer to the same entity. On the other hand, we can have one name for multiple things, and this is more common than, well, it's more common in English in particular than in Spanish, but also for names. A name can refer to multiple things. So the Dublin can refer to a Spanish name for the Irish capital, but it could also refer to an Irish bar in Bahia Vista. And again, from the machine perspective, it's like one string, so it could maybe assume that, there's one thing being referred to here. There are also multiple ways to say the same thing. So Dublin's population is 1 million, Dublin has a population of 1 million, and so forth. So there are many complex ways to express essentially the same information, right? And also in different natural languages. And this is difficult, obviously, for the machines to process. We also have multiple meanings for the same saying. So just taking one sentence, it can mean multiple things. So we can have Sherlock saw the man using binoculars is a famous example of this, which can mean that Sherlock saw the man using binoculars, or Sherlock saw the man using binoculars to see the man, right? So the two situations being Sherlock saw the man using binoculars, Sherlock was using the binoculars, Sherlock saw the man and the man was using binoculars, right? So this sort of case is also, makes it even more difficult for the machine to understand natural language. And also there's a lot of irony, there can be sarcasm, there can be, different types of language used, that non-literal language. In this case, a Spanish example, Fred está arriba la pelota. The machine thinks, okay, finally I understand this one. But of course, the machine is not correct in this one. So these are sorts of challenges for the machine, right? In terms of having the machine understand, natural language and to be able to answer questions based on that. So the machine here gets it wrong. Let me check the time quickly. So we'll have half an hour of class, and it's a good time to take a break. So we can take a 10-minute break and then return for the last half an hour. Any questions or comments or doubts?
I have a question.
Sure.
What happens to the correctness of the sources with semantic, what was the name?
The semantic web, yeah.
Yeah.
So it's a good question. It's the same as on the current web, that essentially there will be incorrect information, there will be spam, there will be, there will be every kind of mix of incorrect, inaccurate, out of date, malicious, etc. Data on the semantic web. A key aspect would be you can use very similar techniques as used on the current web to combat that. So you can do links analysis, you can only trust certain websites, you can rate users can rate how trustworthy a source is. So you can use some sort of social filtering. And an important thing would be that if you give answers or you solve a task using the semantic web, that it provides the references so you could go back and check the individual sources if you wanted. So these are all kinds of, it's definitely a challenge, but it can be addressed in a similar way to the way it's addressed on the current web. It's maybe a little bit more complicated in certain cases, especially for automating something that involves 10 different sources, but it's similar to the current web.
Okay, thank you.
Nice. Any questions or comments? Okay, so we'll take a break for 10 minutes and we'll have the last half hour. I'm going to search for the document. I have Pausa Activa somewhere. I'll post one in the chat in a minute. See you soon. Okay, so we saw this example or these examples that make it difficult for machines to understand natural language. So this is sometimes known as the semantic gap between how humans understand and machines understand content. So what if we could structure everything? So essentially, okay, we have the web currently in natural language, mostly with some links and tables and so forth, but it's mainly structured in terms of text, right? So what if we could start to structure things to make it easier for the machine to understand the content? So what if we could, use one thing to mean one thing, ideally? Okay, so instead of having lots of different ways to refer to something, we choose one symbol to refer to that thing, and we use it consistently. Similarly, instead of using, one symbol to refer to two completely different things, excuse me, what if we have, again, a one-to-one mapping between the symbols and their meanings, right? So we have one symbol for one thing. That would make life simpler. One simple way to say one thing. So we try to somehow simplify a little bit the structure of the content, the language, the grammar. So instead of saying it all like this, we just say Dublin population 1 million, for example. So in that case, this would just be a tuple of fixed length of symbols that encode the information that we need. So these symbols are just arbitrary symbols, right? They're not supposed to have any meaning if you recognize what they mean. That's not intended. So in this case, okay, this sort of question here where, before we're like, okay, this seems, how are we going to solve this, right? This becomes maybe a little bit easier if we consider structuring the content. So this is sort of known as the symbolic methods, or using somehow, working with symbols. And in this way, we can structure the content and also the questions, and then things should become a little bit easier. So what we have here is a question, but this time it's structured, where we have X and Y are variables that we're looking for, okay? So this is sort of, a symbolic question. So what should the output be now? So actually, if we look, it seems a bit more feasible to answer this question, even though we have no clue what it's about, right? So we see that this here seems to match this here, and the symbol here matches the symbol here. So we'd expect X to be maybe this. Okay. And we also see here that it could be that. And then we have the same symbol, this and Y. So we see that this matches, right? So the same value that we found for X here, we also have this tuple here. So we would expect the results to be X maps to this fork thing here. I guess maybe it's Neptune, I'm not sure. These are astrological symbols. And Y maps to the number 1 million. So you might ask, why doesn't 1 million get a symbol? It's because 1 million is actually understandable by machines to a certain extent, in that, you know, you can express 1 million divided by 10 and it can kind of understand that that would be 100,000, right? So since it's a mathematical concept, machines can somehow manipulate that. So we can keep the number. So, okay, in this case, this is the output, and we could, you know, create an algorithm to do this. We could create an algorithm to answer this sort of question over this sort of content. Hopefully you can maybe see how we might do that, right? So symbolically, this becomes a lot easier to automate, right? To create an algorithm for. What we're actually answering is something in the human sense, returning to the human version. We have triples like Ireland, part of Europe, Ireland is a country, Ireland capital Dublin, Ireland capital Dublin, Dublin population 1 million, and then our input is Ireland capital X, X population Y, right? So what is the population of the capital of Ireland was the original natural language question. And we see the output here from the human perspective. So what about in this case, if we take this question, it looks almost easier, right? But there is a complication to this question. So we have the same content. We have, you know, 5 triples here representing the content of the web page, and we have X, this thing here, which means solar, I think, or Jupiter, I'm not sure. Anyways, this symbol here, we're not supposed to know what they mean, and Y. So we see, if we look through the different triples, we see a match with this one here, right? So this symbol fixes, so we'll map X to this H-like symbol here, and Y to this symbol here. Maybe it's Aries, I'm not sure. So we have X maps to this symbol here, and Y maps to this. So this is even easier because we don't have to join anything like we had to before. We just have one tuple in the input. But actually, there's some complications here, because if we look at what this question means in the human perspective, we're asking for things that are parts of other things. So X is part of Y. So we've answered that Ireland is part of Europe, and that's the only answer we have in this content. However, as humans, we understand the concept of capital, and we might think that that would imply that Dublin is part of Ireland, right? So we can't just simply do some syntactic matching like this, like we saw, but we also need to, if we really want to be able to automate these sorts of questions and emulate an understanding of the content, we would need to understand as well the meaning of terms like capital is a part of population, right? So we would need that to be able to generate an answer that's implied by the content, not explicitly given, such that Dublin is part of Ireland, right? So what we would need additionally is not just structured input and structured content, structured queries and structured content, but also potentially rules of this form. So this says that if we have a triple like this, B symbol A, then this implies A, this symbol B, right? So if we apply this rule to our content and we go looking for where we can apply it to this triple here, which is actually the same as this triple here. And what we're going to create is a new triple based on this rule, right? So now what should the output be? So if we apply this rule, we see then that the result of applying this rule on this triple will actually create a new triple that matches this input here. So essentially what we get is a new answer. We get an answer that this thing here is maps to X and this thing here maps to Y. So what does this mean? If we return to the human form again, we look at this, we see that what we're expressing is a rule that B capital of A implies A part of B. Yeah. And if we apply that rule here, Ireland, capital Dublin, we'll get that Dublin is part of Ireland. Okay, and that allows us then to create this additional answer that Dublin part of Ireland in our output, right? Can anyone see another possible answer implied by the content?
Si Dublín es la capital de Irlanda, Irlanda es parte de Europa, entonces Dublín es parte de Europa.
Exactly, yeah. So we have this, we should also expect that Dublin is part of Europe, which is known as transitivity. So what we'd like is a rule that encodes the transitivity of part of to be able to imply this result here. So how do we do that? We add another rule, right? We say that A, the symbol B, B, the symbol C, implies A, the symbol C. Okay, so we add another rule. We have the same question, we have content, and now with this additional rule, we can find additional answers. So we can find 3 answers this time, okay? So what's the additional, what does this look like from the human perspective? Well, we have the same rule as before, plus this transitive rule for part of, A part of B, B part of C, A part of C. So now Dublin part of Ireland, Ireland part of Europe, Dublin part of Europe. And this allows us to get this additional answer, Dublin, Europe. So overall, more or less, this is, you know, a sort of a very high level overview of where we're going with the semantic web, where we have data, structured data on the web, structured in the form of triples. In fact, the structure itself, one can argue about different structures, but we'll argue why this is a useful structure. It's essentially a graph, as we'll see later. We have logic, which can be in the forms of rules or something called ontologies that we'll talk about later, that define the meaning of the terms used in the data. So what does capital mean? Or what does part of mean? Not so much what does it mean, but how does it relate to the other terms that are used? For example, capital implies part of in the other direction, or part of is a transitive property, right? So we can have this sort of inference over it. So this allows us to not only answer questions over the explicit content, but also over the content that's implied, what is implied by the content. Then we have queries, which are structured to match in a sort of symbolic way, in a sort of similar to a relational database or whatever database, the content. And then we have our output, right? So key concepts here are data, logic, and queries, okay? So there's a couple of other elements that we'll see. So this is sort of more or less, but for now, this is a sort of a useful insight into where we're going with this concept of the semantic web. So we need to really think about what's the best way to structure data on the web. How do we define the logical part? How do we write queries over this content? And other questions would be, how do we link different documents? How do we navigate crawl documents? You know, how do we do the webby part, right? How do we put all this on the web and interconnect it and make it work? Okay, so this is the semantic web, the overall concept, and we're going to be talking in different classes about different elements of this. Data being the RDF data model, logic being the RDFS and OWL ontologies, and queries being Sparkle. Probably the part that's, you know, most different will be the logic part. So we'll spend some time talking about that. As opposed to data and queries, which are kind of similar to what you might have seen in a database course, with some differences, some important differences, which we'll discuss. Okay, so any questions or doubts? If not, yeah, so the semantic web has been around for a long time. So where is it, right? Is there anything to show for all of the work? I've been working on the semantic web. I started working in a research institute in 2005 as an intern. So I don't know how long ago that is, but it's a long time ago. Is there anything to show for all these efforts? And I've been working on it since 2005. So we're, you know, is there something we could look at? Where is the semantic web? So the semantic web, yeah, where is it? yeah, there's lots of papers to show for it. That's for sure. So the answer is that the semantic web is hidden within the web. So what does that mean? It's sort of like saying, you know, it's not something that you're going to see on the surface. It's something that will be hidden beneath the applications you're using. So you need to almost open up those applications, and you can start to find kind of traces or elements of the semantic web. In fact, you're in an indirect way using, I would say, not using the semantic web, but using different technologies of the semantic web every day when you use the web. You may not realize it. So one of the things where you might see the semantic web, and it's something I've introduced as well in database courses and so forth. It's a project I like a lot, which is called Wikidata, which is a Wikipedia for data. So you may or may not have heard of Wikidata. It's not so well known, I would say, not half as well known as Wikipedia, but essentially it's a structured version of Wikipedia. We could think of it. It's managed by the Wikimedia. It's managed by the same organization that manages Wikipedia. And the purpose is to collect together and edit as almost like a wiki, but using structured data to describe the entities that are contained within the wiki. So before we discuss what is Wikidata, it's good to discuss again why do we need Wikidata? What's the purpose? So Wikipedia has various problems associated with how it manages its structured data. So it manages structured data in the sense that these are called info boxes. If you go to the page for Alexis Sanchez on Wikipedia, you'll find data effectively here in an informal syntax. So we have as well Wikipedias in different languages, right? And one of the kind of, it's based on its origin, but essentially Wikipedia is edited by users. Okay, it has some bots to help with certain things, but predominantly it's edited by hand. So this can create some problems. In particular, if we look at this information across the different languages, across English, Spanish, and German, we see that we have 82 golds here. These were taken at the same time. So this data is now a little bit out of date, but we have 82 golds. But if you speak German, he's only scored 76 golds for the national, or 76 appearances, I guess, sorry, 82 appearances and 76 appearances. And he's scored 25 golds rather than 26. So we see that the data are not consistent across the different language versions. And this is because, you know, for this data to be updated, a German speaker, more or less, would have to go into this page and edit it by hand, right? So there's no way to automatically update the data across all the different versions, all the different language versions. Also, we should consider that the goals that Alexis Sanchez has scored can also appear in various different locations. For example, there can also be tables that describe how many goals different players have scored in the Chilean national football team, or there might be also, you know, how many scorers per tournament, you know. So this information can appear not only across different languages, but in one particular language, it can appear in lots of different articles in different locations. So as a consequence, when Alexis Sanchez scores a goal, what this implies for Wikipedia is that effectively an army of editors now have to go and update this goal in the pages for the tournament, the pages for the national team, the pages for Alexis Sanchez, the pages, you know, all these different locations. So this is really, you know, this is not ideal, to say the least. This is sort of like a lot of manual effort that Wikipedia is asking people, you know, and it seems perhaps unnecessary. But how would you solve it, right? How would you address this? Well, what Wikimedia have decided to do is embark on this Wikidata project, where it's a central repository of data that can be used for various Wikimedia projects, including Wikipedia, for example. And it's multilingual, right? So this is machine readable, multilingual. It means we can do queries, process automatically the content, we can do queries over it and so forth. One of the key things is that it's multilingual in the sense that we we assign labels in different languages to different entities and properties and so forth, but we do not duplicate the data. So the data are the same. We have these identifiers that represent the data, and then we just give different labels for those identifiers. So if we add a new fact or a new claim to Wikidata, it's also available in other languages, assuming we have the labels, at least of each element in each language. So it's multilingual in that sense. So we have, for example, the information about Alexis Sanchez and the same information in English, in Spanish, in German, in, I don't know, Russian, maybe Cyrillic.
Russian, so yeah.
And I have no idea. We see here, in fact, that just to point out that, you know, if we don't have labels in a certain language, it will display by default some other language. But if we have the labels of the entities, we can use those. Tamil, it's a Southeast Asian language for sure. I'm not sure which. I don't remember. So yeah, so this is kind of cool, right? This means that we have all this data that we can surface in all these different languages. And Wikidata describes 71 million entities, similar to Alexis Sanchez, for example. We see a list of, you know, the different types of entities that are most common: humans, taxons, which are like species and subspecies and families and kind of biological taxons; administrative territorial entity, which is effectively places; buildings, events, chemical compounds, movies; thoroughfare, which is streets and roads and stuff like that, I guess; astronomical objects and so on. With 23,000 users active in the last 30 days. So these people are, you know, for example, editing different entities and adding more information. So I promised you, you know, if you might say, I've never used Wikidata. I still, you know, you said that we probably, you know, touch upon the semantic web quite often. One use case for Wikidata is that you can see now in some, not all, info boxes on Wikipedia, that in fact you don't edit the info box as in the document itself, but rather you'll see a pencil that will ask you to edit the information at Wikidata. So the data are coming from Wikidata directly, right? And if you edit it, you will edit it on Wikidata. And the benefit of that is that the languages in which this Wikidata info box is available, the data will be synchronized across those languages. So if you make one change here, it can be propagated to all the language versions of Wikipedia. Given that the data are structured, we can also use it, for example, for quality checks. We can check the information that's present in Wikidata and thus also shown on Wikipedia and see if there might be some issues. For example, we can check the ages of people. We can query for people of different ages and people with ages that seem a bit suspect. For example, a list of people who have do not have an age between 0 and 130. So we have people with 134, 150, and so forth, and we can check to see if that's really the case, or if there's maybe a problem with their birth or death that we can, ask some users to revise or to check out. And we might say, okay, well, maybe some of these cases are valid, and some of them are. Some of these are, fictional people, or they're religious figures, or they had a very long life in some cases. So maybe there's an argument to be made that that's okay, but then we find the people who have negative ages, and that's maybe a little bit more difficult to explain away, right? So someone who's minus 220, who died 220 years before they were born. So, this allows us maybe to improve the quality of Wikidata and thus of Wikipedia. This would be very difficult to do if we were just working with Wikipedia kind of directly, right, with informal info boxes. And we can also write queries. So this is in a query language called Sparkle, but we can actually write and express the query about that we had at the start about Nobel laureates that have fought in a war, the year they won the award and the year of the war. So we'll see this language later in the course. And here we see some of the answers that have been returned. So we see some of the laureates of literature, the wars that were involved in, the years of the awards and the war. So this is essentially, because we have now a structured version of Wikipedia, we can answer these sorts of questions. This query service is available to anyone. You can go there and run the query. So, okay, Wikidata is also used in applications like Siri. So we don't know that because Apple and Amazon and all these sorts of companies, they don't often reveal a lot of data about, you know, a lot of information about what data sources they're using. But Siri started telling people that Stan Lee was dead before he had actually died. And this became a news story, and some people traced it back to an edit on Wikidata where someone added as vandalism, they added that Stan Lee had died. And that was the only sort of public source of information that people could find with this fact, and it coincided in terms of timing. So the assumption is that Siri was at that point using Wikidata because it was repeating the erroneous fact that was added to Wikidata. So yeah, another example, or any questions or comments? Okay, so we also, if you use Google, I'm sure many of you do, you'll find this panel here on the right-hand side of the results pages. And this is also relating to the semantic web, to structuring the content of the web. So this is called Google's knowledge panel. And the idea now is that we're not just doing this sort of substring matching or this keyword search or information retrieval, but Google is actively trying to understand what the person is looking for. Is it a book? Is it a person? Is it a poet? Is it, what is it, right? And trying to show some information about that entity. So what Google refers to as things, not strings, that you're searching for something rather than searching for a string and match in a document. And we see some structured data here that's sourced from various places, including Wikipedia, probably Wikidata, although again, it's unclear exactly which sources are used, and various other sources. So Google used to have something similar to Wikidata called Freebase. And it shut down Freebase in order to migrate the data to Wikidata as an open source platform for structured content. Another example of the semantic web are in so-called rich snippets, which are the fancy looking search results that you get now, where you have an image and you have some rating and you have some information. For example, if you search for recipes, you can see how many reviews there are, rating, how long it takes to prepare, how many calories it involves. And this is relatively new. Originally, there were, in Google was just title of page, paragraph, and some matches of keywords. Now we get these sort of results that allow us to browse different options directly in the results page. So if you think about it, you've probably seen this, right? But if you think about it, how does Google do this? How does Google extract the ratings, especially from different websites? If it were just HTML, you could imagine this would be quite a difficult task to do this accurately over all the different websites that are out there, right? Especially, converting different rating schemes, from 1 to 10, 1 to 5, 0 to 5, 1 to 100, this would be very difficult. So how does Google do it? In short, Google doesn't. So Google does know about the ratings in minutes and calories, but it's not extracting that information from the web pages. Rather, the publishers add structured data. So they actually insert data into their web pages to say, hey, this is how many calories are in this recipe. For example, here, this has nothing to do with displaying the web page. So the web page looks exactly the same, but essentially it's injecting structured data that Google can scrape or extract very easily from the web pages and use to build these snippets. So why do publishers bother to do this? This looks like a lot of effort. Well, essentially, the publishers get more clicks on the results because their result looks all shiny and there's a picture and ratings and so forth. And as well, Google gets to make the data look more fancy. And the users also win because users can now browse the results page in Google and see a summary of different alternatives. As another,
I have a question, teacher.
sure.
How does a publisher know what type of data they should add to be in Google?
Yep. So there's a vocabulary called schema.org, and that describes different classes and different properties. So the classes would be things like movie, recipe, product, building, event, and the properties then, for example, in the case of recipe, class would be things like calories, duration, rating, and so forth. So you would, let's say you have a website about movies, you would go to the movie class and then you'd see a recommendation of properties that you could use to define movies. And it forms a graph because the movie might point to an actor, and then you would have a person class that you could, so you can start to expand your data from there.
Okay, thank you.
Yep. And the good thing is, Google, not only Google, I'll speak more about schema.org later, but it's not just Google proposing that, but there was an agreement between major web companies or search engines to all use that vocabulary. So you don't need to use different vocabulary. When I say vocabulary, for example, this term calories, it's the same for Yahoo, Google, Yandex, and Microsoft for Bing. They will all understand the same format and the same data. Yeah, so this again is all based, it's kind of an initial version of the semantic web. It's kind of very simple data, but it's still, it's still follows the semantic web idea. And to briefly mention as well that, semantic web has been used a lot for publishing open data. So essentially, we have this question of how do you publish open data, where there's this 5 stars where PDF is the worst you could do. If you have a table, for example, or some data, publishing it as a PDF is an awful idea. At least it would be better in Excel, but Excel is a proprietary format, so even better if you just publish it as a CSV. And then these latter 2 steps, essentially this refers to using web identifiers to identify things like countries or people or whatever in the data, not just a string like Ireland or Chile, but to maybe use a Wikidata identifier to identify it. And then this refers to interconnecting all of that content. So we'll speak more about this later in the course, but essentially it can be seen as a standard way to publish open data you want to make available to everyone, to the public. This is called the 5-star linking open data scheme, which we'll return to in a while. But to mention that various companies and organizations have used the semantic web standards to make data publicly available in a machine readable format that can be easily queried and processed. We'll speak more about that in the latter part of the course. So about the course itself, we're going to cover these topics mainly. We're going to talk about RDF, which is the data, RDF SNL, which relate to the logic. We're going to talk about Sparkle, which is the query language. We're going to talk about linked data and the web of data, which is this idea of really connecting together this content to this data to form a web. We're going to speak then briefly about 2 other important concepts. One relates to importing legacy data, in particular relational databases, into the semantic web. So we'll discuss relational database to RDF, RDB to RDF, and we'll discuss how to validate data to ensure better, higher quality of data. Lots of these are based on web standards that have been, standardized for over a decade in some cases. These topics, all towards introducing this idea of the web of data. In general, it's a research course, so it's a little bit different. Maybe if you've not taken, such a course before. When we talk about relational databases, we talk about tools that have been around for 40 years and so forth. Things are a little bit new. They're still under definition. Things might change, and there's some things that we still don't have answers for. And, I'll try to make that clear at certain points. So, there's it's an ongoing initiative. It's, getting adoption for sure, as we discussed, but, there's still a lot of open questions about how this might work. And yeah. The structure of the course will be, so if you've taken a previous course with me, this will be very familiar, but if not, there will be a class on Monday, There will be a lab on Wednesday, and we'll have an auxiliary session on Friday. So essentially, the labs will give you like a tarea that you can do during the class. We'll be there to answer questions. We'll have a lab on Wednesday, this Wednesday coming, and we'll organize those in Discord. The labs in general, or the marking, okay, let's go to the marking. We'll have 70% labs, 20% project, and 10% reading groups. So in general, there are about 10 or 11 labs. The core ones will be, I don't remember exactly how many. I'll publish the data on Cursos later, but some of those labs that are considered sort of integral for the course will be mandatory, obligatory, which means that their grade will count for sure. And then others will be optional, so you can do a certain number of the optional labs. The project and the reading group, the project will be, you define an interesting topic for you and use something from the course to resolve that problem. The reading group will be essentially you choose a research paper of interest to you as a group, and you'll prepare a short video explaining presenting the research paper. And the idea is that together with all of the videos, we can get a kind of a nice summary of different types of research that are going on in the area. So this is the marking structure. Just to mention, you don't have to pass anything. You just have to, your overall grade has to be a passing mark. So it's not like if you fail the project, you automatically fail the course. If you have a sufficient, grade in the other parts, that's fine. Bibliography. I'll publish a book later on Cursos that you can use. It's a bit more detailed than what we're going to see in the course, but all the elements are in there for more details. Outcomes. You can learn about the Semantic Web, which is an ongoing research topic. There's various people in the DCC who've been working on or are working on the Semantic Web as a research topic. How to apply different concepts you might have seen in other courses like databases, logic, artificial intelligence, but a different kind of artificial intelligence, not kind of learning inductive based, but deductive based to the web. Mix of theory and practical exercises, and maybe hopefully learn maybe something about the future of the web. Any questions or doubts? About the course.
Profe, ¿de cuánto van a ser los grupos?
And that's a good question. I'm still waiting to figure out certain details of the course. So I still don't know exactly how many students we'll have and so on. But in general, it will be 3 for the reading groups. Probably be 3 for the labs. It will probably be 3 for the projects and reading groups as well.
Vale.
Para hacer trabajar en grupo durante los laboratorios, hay que ir a la sesión de los miércoles o no?
To work in a group, you would attend on Wednesday. But if you can't attend on Wednesday, I'll have to talk to auxiliaries. There are various details I still need to organize for the course, depending on how many people there are, how many auxiliaries we have as well. But you could also hopefully attend on Friday. Once we sort out the teaching team, we can confirm that. But you can attend on Wednesday or Friday as part of the group. If you can't attend on Wednesday or Friday, then you can still work alone, but not submit as a group.
Vale.
¿Va a haber lavatorio este miércoles, profe?
This week was the question. Yeah, it's a very informal lab, and it's mainly just to to motivate the course, but also to get used to Discord and to maybe see or underline some of the challenges with the web. So we're going to give you, I know you probably all think you're experts at Googling, especially the students from the DCC. Can Google your way through any problem. So we're going to give you some problems that are challenging, just questions that you can resolve using the web, and you'll have to use your Google skills to try to answer them. So we'll try to design this is to kind of to motivate, but also it will be useful as well, just to get used to Discord and all of that. Yep.
Grading for the labs will then also be group-based or individually?
The labs project and reading groups will be a group. There will be group grading for that. It might be possible we can look into it for the projects to see if there might be some co-evaluation there. But in general, the marking will be in the groups that you've submitted the work with.
All right, thanks.
No other questions?
Teacher, could you repeat what's the reading group evaluation about?
Yeah. So the reading group, we will post a list of like conferences and different venues, or you can also use search engines like Google Scholar or DVLP or whatever you'd like. So we'll define some criteria for different search for research papers, so that they should be about the semantic web. They should be of X length at least, at most Y length. They should have been published in one of these places to ensure essentially good quality research papers. Then you can go and search and look for papers of interest to you. If you're interested in a particular topic, like for example, clustering or classification, or you're interested in particular applications like music, or you're interested in, you can search for research papers relating to the semantic web on whatever topic is of interest. That's as a group, so you'll have to discuss with your group and select a good paper. Then as a group, you'll read through the paper, understand the paper, and then present a short kind of summary of that research paper. And then you'll be graded on the video that you present. The goal would be that you can, the goal is that, okay, this is a postgraduate course, so you're kind of more adjacent to the research. You're actually reading research papers. But I think a nice goal as well, or a nice result of that, is that watching the videos of other groups, you get a nice kind of summary or selection or sample of different types of research going on in the area. So yep, that's the reading group. Pick a paper, research paper, prepare a short video, a short presentation about that paper. And that's done as part of a group.
Okay, thanks. But then like the project is just one evaluation, not like weekly?
The project, yeah, so the project and the reading group will have final evaluations. Yeah, there's no like ethos, or there's no stages or something like that.
Okay, thank you.
Okay, no more questions or comments? Okay, so if not, I'll see you in Discord on Wednesday. So the labs will have in Discord, I'll publish the instructions on how to access and so forth. So hope you have a smooth start to your semester, and see you soon.